Alright guys, welcome to Calc today. Basically I was planning on doing this on the smartboard, but instead we're going to have to do it here on my kitchen table with a pen and me holding the camera. Okay, so for our warm-up I want you guys to find the equation of the tangent line to the curve y equals sine x plus x at x equals 0. So that would be the equation of the straight line. And then use that straight line to approximate sine of 0.1 plus 0.1 without a calculator. So go ahead and pause this video. I'll give you guys some time, and then unpause it to see the solution. Alright, welcome back. So we get that dy dx is going to equal cosine x plus 1. So we're going to evaluate that at x equals 0, so that means it's equal to cosine of 0 plus 1, so that would be 2. And since it goes through the point 0 on x and 0 on y, its y-intercept is 0, so we have y equals 2x as the equation of the line. So that's the straight line approximation. So now let's evaluate it at sine of 0.1 plus 0.1. So basically we plug 0.1 into this equation. So y equals 2 times 0.1, which equals 0.2. Now, if you actually have your calculator, which I don't, go ahead and plug in x equals 0.1 to sine of x plus x. And you should get an answer remarkably close to 0.2. And that's the bottom line of what we're going to try to do today. We're going to use calculus to come up with ways to approximate functions without actually creating the equation of the tangent line. Okay, so how are we going to do that? Well, let's start out by looking at a general curve, and let's say that the change in x is delta x and the change in y is delta y. Now that should be a very familiar graph. That's the definition of slope you've had since Algebra 1, or maybe even before then. The new slope has to do with a very similar graph, but now, sorry about that, we're going to project a tangent line from the point x comma y, and the slope of that tangent line is given by dx and dy. Now if you'll notice, delta y is slightly larger than dy. Now for most situations we can say that delta y is approximately equal to dy. Okay, and the same thing for delta x and dx, but I think that this graph makes it clear that dx and delta x are very close. Now, how do we do this? Sorry about the focus. Let's define some notation stuff. F prime of x is equal to dy dx. Those are alternative ways to write the derivative. So what I'm going to do is I'm going to cross multiply. So I get dy is equal to f prime of x dx. That is to say that the change in y is approximately equal to the slope of the tangent line multiplied by the change in x. So what we're going to do next is we're going to apply this to a simple function. So play the next video.